This is the screencast for section 3.9, example 4. We're going to go the long way with the chain rule. Don't worry, it's not that long. Find dy dx if y equals log base a of a to the sine of x. I know you're saying, well, but this is log base a, so the base of my log is the same as the base of my exponent. I can just simplify it. It should be sine of x. I know my answer is going to be cosine of x. Yes, you do. You know the answer. Wonderful. We need to go the long way and use the chain rule, like the directions say. So we have a log base a of u situation. Now our u is a to the sine of x. So it itself is an a to the u. So we really have a three-layered problem here, three-layered chain rule. Y equals, we've got this log base a of u. And then in that u, we have a sine of x as the exponent. So it's a three-layered chain rule. Well, the derivative is going to be, let's see, the derivative of log base a of u is 1 over u times the natural log of a. But now we need to multiply by the derivative of that u. The derivative of this u is going to be, well, it's the derivative of a to the u. So the derivative of a to the u is the natural log of a times a to the u, but then we got to multiply by the derivative of the u, so that would be cosine of x. So again, here's the first layer dealing with log base a of u. Then here's the second layer dealing with a to the u. And then here's the third layer with just taking the derivative of that exponent, which is cosine of x. So now let's simplify some things out. Oh my goodness, look at that. As if you didn't know that was going to happen. So the derivative is in fact cosine of x. Yay. The now try problem asks us to find just the plain old log, doesn't give us any rules that we have to follow, don't have to use the chain rule. I am, however, going to change that 1 over x to x to the negative 1, because I think that's just easier to work with instead of quotient rule. So now I have log base a of u, so the derivative is going to be 1 over u times the natural log of a, the base, times the derivative of u. So u is x to the negative 1, that's going to be negative x to the now negative 2. Do some simplification, and I get the opposite of 1 over x natural log of 2 as the derivative of y.